Okay, so in this instance, we've got a reaction between H₂O and PCl₅, right? So that's phosphorus pentachloride, and that reacts to produce H₃PO₄ and HCl. So that's phosphoric acid and hydrochloric acid. What I actually have here as well is this is basically a sketch of the phosphoric acid, and over here we've got the phosphorus pentachloride. So this is just more of a sketch version and then a 3D version. Anyway, so what is the question actually asking us for? The question is asking us to calculate the mass of H₃PO₄ produced in the reaction. And when we look at the question, we have been told the mass of the H₂O, right? Now, we have not been told the mass of the H₃PO₄, right? And if you check, we have not been provided the moles either, at least not directly. But we can work out the molar mass of H₃PO₄ from the periodic table. If you take a look now at the equation, so this relates the the mass, the moles, and molar mass, right? So the mass would be the number of moles multiplied by the molar mass, right? So we have an easy way to get this. Getting the moles is not as straightforward. We're going to focus on getting the moles at this stage, and we can get the molar mass later on from the periodic table. Okay, so how are we going to go about getting the moles? Well, in the question, we've been told the mass of H₂O that reacts, and we've been told that the PCl₅ is in excess. So the main limiting reagent here is the H₂O, and because of that, we can use that mass of H₂O we've been told to work out effectively on the stoichiometric level how much H₃PO₄ is actually going to be produced, because it is going to be contingent on that mass of H₂O. Okay, so let's go about that process. At this stage, what we would want to do is work out the number of moles of H₂O. So we've been told the mass, we haven't been told the number of moles. The number of moles, we know from the equation, is going to be equal to the mass divided by the molar mass, right? So we've been told this in the question. This would need to work out from the periodic table. So let's work out the molar mass of H₂O, which you may already know, to be honest. But hydrogen, we've got 1, and carbon, we've got 12. Well, not carbon. Why am I looking at carbon? Oxygen, we've got 16.0. Okay, so for hydrogen, we've got so MR of H₂O is equal to so we effectively, what we need to do is take the relative atomic masses and incorporate them proportionally to what they how often they show up in a formula. So that's going to be so 1 times 2, so that's the 1 from here from the hydrogen, times 2, so H2, plus 16 from the oxygen, right? So 16, and that's basically times 1, but I'm not going to write the times 1 there. We don't really need to write it, but you could if you wanted to. And that's going to give us what? That's going to give us, of course, 18, and that's in grams per mole, right? Now, on the other hand, we already have the mass of H₂O, right? So we just need to take that molar mass and use it with the mass. So therefore, the moles, so this is going to be, to make things clear, I'm going to write moles of H₂O is equal to, right? So we're going to, basically, we need to combine the 38.68 with the 18. So 38.68 divided by 18, okay? And what does that give us? Well, if you work that out, you should get 2.148889, and that's going to be in moles. Now, what do we do with this value? Because we've got the moles of H₂O, but we're obviously been asked to work out the mass of H₃PO₄. Okay. Now this is where the stoichiometric relationship between H₂O and H₃PO₄ becomes very important. And if we set that up in a formal, like a slightly formal way in writing, effectively, moles of H₂O compared to this ratio to the moles of H₃PO₄, right? What we find is that the ratio between the two, as you see from the coefficient. So we're looking at the coefficients. You see for H₂O you've got a coefficient of 4, okay, and for H₃PO₄, effectively your coefficient is 1, right? So it doesn't have a coefficient written there, but it would be 1, right? So for every 4 moles of H₂O, you're going to have 1 mole of H₃PO₄. So that's going to be a 4-to-1 ratio, right? And what are the implications of this as far as the mole figure we've calculated? Well, simply put, what this tells us is that the moles of H₃PO₄ can be calculated by taking the moles of H₂O and dividing it by 4. Okay, and obviously dividing by 4 is the same as multiplying by 0.25, so we can say that the moles of H₃PO₄ is equal to 0.25 multiplied by 2.14888889. Okay, so feel free to work that out and see what number you get out of that. And if you did have a go at that, what you should have found is you got 0.5372222. Okay, and that's going to be in moles, right? So moles. Now that we actually have the moles, we can go back to the equation that we started with, which, as I said at that time, the working out the molar mass for H₃PO₄ is relatively straightforward, but we needed to work out what the number of moles was, which now we've done. So let's go back to this side and let's actually work out what that molar mass is. So to do that, we refer back to the periodic table again, and here we're looking for the MR of H₃PO₄, right? And so for H3, that's 1 times 3, of course, right? So 1 times 3 plus, and so for phosphorus, we've got that here, so that's going to be 31, right? Plus 31 plus, and then for O4, so for oxygen, as you can see, is 16. So it's going to be plus 16 times 4, right? And so that's going to give us the molar mass of H₃PO₄. And if you work that out, you should have found that that's going to actually equal 98, and that's in grams per mole, right? Okay, so we've got the molar mass of H₃PO₄, and we've got the moles of H₃PO₄. So of course the next step is simply to multiply the two as per this equation, and this will tell us the mass, right? So here we can say, therefore the mass for H₃PO₄ is equal to 98 multiplied by 0.5372222, right? And if you work that out, you should get 52.64777776, right? And that's going to be in grams. So we have actually got a figure for mass now. So let's just double check what we've been asked to do. And it says calculate the mass of H₃PO₄. So we've done that, right? And then it says give your answer to a maximum of 2 decimal places, right? So if we go back to what we've got so far, we've worked out a mass, but we haven't quite, quote unquote, worked out the answer in the format which has been specified. So we are then needing to do some rounding. So that is therefore equal to effectively 52.65 grams. So that would be, in this case, this would be our answer, right?